In this video, let's take a few minutes to go over the setup of the Eagle-Eye GigE camera timing system with the legacy trigger. Here are the components we're working with today. First, we have the GigE or Ethernet-based timing camera, which can easily be determined by the Ethernet port on the back of the camera. We also have the Cat6 data cable and the two-piece power supply to the camera, power supply itself, and the power cord. Make sure the power cord is fully seated into the power supply. And here's a quick tip with the camera. Make sure to remove the lens cap. Second, we have the USB key, which is required for the system to operate as a recording timing system. If this is not plugged in or you have not imported your license key file corresponding to the USB key, you will get a message, "No valid license found," and your software will be a read-only version. Next, we have the legacy wireless trigger, which can be identified by the blue protective case and or the 9-volt battery capacity compartment. USB trigger cable, antennas, power supply for the wireless trigger receiver unit. It is very important you use the correct power supply for this unit or damage can occur. For those still using the USB audio adapter, make sure the audio cable coming from the back of the wireless trigger is plugged into the microphone port on the USB audio adapter. On this unit, it is the red port. Before we start making connections, let's take a look at a couple of other essential items to identify and address regarding the connection of the camera to the system. This camera is a PoE-enabled gigabit Ethernet camera and requires connection to the computer with a gigabit Ethernet port. Not only that, but, and this is a big but, the Ethernet port the camera is plugged into must have support for 9K jumbo frames, which in basic terms are very large packets of data transmission. These cameras send large amounts of data and the computer has to have a pipeline to be able to ingest it. The computer we are working with in this video demonstration happens to have an Ethernet port built in that does have 9K jumbo frame capability. However, many newer computers do not have a built-in Ethernet port, and an Ethernet to USB 3 adapter like this one can be used. Just like the built-in port on the computer, this adapter must be able to work with 9K jumbo frames. Without this 9K jumbo frame feature, you will not achieve an image. This is a setting we will be adjusting later in this video. Another item that can be used is a PoE switch like this one. It can supply power to the camera through the Cat6 Ethernet cable, eliminating the need for the camera power source. A PoE switch can also add distance beyond the 300-foot barrier of Ethernet cable usage, with up to an additional 300 feet going to the computer from the switch. Just like the built-in Ethernet port on the computer and the Ethernet to USB 3 adapter, this device must also have support for 9K jumbo frames and will be listed in the specs of the device if it does. If it does, unlike the Ethernet ports on the computer or Ethernet to USB 3 adapter, there are no settings that need to be made. It will automatically engage this feature when components are plugged into it. Now let's start making connections. First, with the computer already on, power on the camera and then connect the Cat6 Ethernet cable to the back of the camera and then to the computer. You can confirm the camera is on and data is transmitting between the computer and camera a couple of ways. This computer has LEDs on the port it was plugged into, and they become active once the camera is plugged in. They would not become active if the camera was not powered on or you have a damaged or failing Cat6 cable. You can also rest your mouse on the Internet Access icon in the lower part of your screen in the system tray. After plugging in the camera to the computer, a small window will appear and you will see the word identifying. This means the camera is powered on and it is negotiating with the computer to establish a connection. One of the most common mistakes at this point is starting up the Eagle-Eye software before the camera and computer have established a connection with each other, which can take 20 to 30 seconds, depending on your computer. Once the word identifying changes to unidentified network, connection has been established. Now the legacy wireless trigger. First, attach the antennas to both the receiver and transmitter. Make sure they are tight, but don't break off the threaded spigot. One way you can tell if your antenna is damaged is by taking the antenna to a quiet location, holding it with your thumb and pointer finger and shaking it like the old mercury thermometers. You're listening for a rattle. If you do hear a rattle, it means your antenna has broken off on the inside and needs to be replaced. A broken antenna greatly reduces signal strength of the transmitting signal to the receiver. Connect power to the wireless receiver. Confirm the unit is on by the power light on the front. It is very important you use the correct power supply for this unit. Just like any other electronic component, you can cause damage to the unit if the wrong power source is used. The power light will flash or pulsate if this occurs. Plug in the USB trigger cable to the back of the receiver and the other end into a USB port on the computer. Power on the transmitter. Data lights on both units will flash momentarily, signifying they are paired to each other. Here's another tip for the legacy trigger. This is how to pair a transmitter and receiver to each other. With the transmitter turned off, press in on the receiver's Learn button, and the Learn light will come on for 8 seconds. During those 8 seconds, turn the transmitter back on. The Learn light will flash 3 times, signifying successful pairing. Now plug in the USB key. This key is essential to the system to operate as a timing system. Without this key, you have a read-only version, meaning you can only read previously recorded races, and you will not be able to time events. Now let's start up the software. We can see we have achieved a live image coming from the camera. For those encountering the grabber initialization failed message upon the startup of the GigE software, the first place you want to check is your jumbo frame settings. 95% of the grabber initialization failed messages are related to this setting alone and can be easily overcome. On the computer, type in Device Manager. Scroll down to and expand Network Adapters. Locate the controller. On this computer, it's the Intel Ethernet connection 1219-LM, and right-click. Click on Properties. Click on the Advanced tab. From here, locate the item referencing Jumbo. This could be jumbo frames or jumbo packets, and set the value to 9014 bytes, also known as 9K. While we are here, locate Speed and Duplex and set the value to the highest listed setting. In this case, 1 gigabit per second full duplex. If you have receive buffers and transmit buffers, set those values to the highest settings possible. You may need to type this in and hit enter on your keyboard. And finally, click the Power Management tab and make sure Allow the computer to turn off this device to save power is unchecked. If you are using the built-in Ethernet port to the computer and don't see the jumbo frame option, and have ensured the drivers are up to date, that port will not work for this application. If you are using the Ethernet to USB 3 adapter that came with your system and don't see the jumbo frame option, you will need to download and install the full set of drivers, which can be found in our GigE Get Started Downloads folder. Contact GigE by email if you need access to this folder. Back in the program, we see the software opened with a live image and to the Race Trigger tab. Notice there is no device selected in the Choose Your Device drop-down menu. You must use this drop-down menu to select the corresponding wireless trigger you have connected to the timing system. The options are 900 series USB audio, which is selected when using this device, which corresponds with the 900 series print on the wireless trigger transmitter and receiver, and uses a shorter whip-like flexible antenna on the transmitter. The other choice is the legacy USB audio option. Select this when used with the legacy wireless trigger, which looks like this. It uses a hard-sided, rigid antenna on the transmitter and has Pro Timing printed in the GigE logo on both the transmitter and receiver. In this demonstration, we're using the legacy wireless trigger and have selected that in the Choose Your Device drop-down menu. Arm the system and give a slight tap to the outside of the transmitter. We hear a chime, see the time code has started, and triggered in green letters, all confirming the start of the race. From here, we can align our camera on the finish line, make adjustments to our image, import events, and get ready for the first event. Be sure to check out some of our other videos where we go over how to use the system, tips and tricks, as well as troubleshooting. Thanks for watching.